Hello, welcome to part 2 of the lesson on quadratic functions. Make sure you've seen video lesson 1, which introduced vertex and standard form quadratics. In this lesson, we're going to look at the third main type of quadratic. So let's recap where we've come from. We've looked at vertex form quadratics in the last video, and we've looked at standard form. In vertex form, we noticed that this h value here is the equation of the axis of symmetry, and the h and the k taken together give us the location of the vertex. That's why it's called vertex form. In standard form, we can change vertex form by multiplying this part out, expanding it, and creating this quadratic. So easy change from vertex to standard form. In standard form, we saw some interesting things as well. The c value is our y-intercept value. Then a value in front here told us how wide or narrow the parabola is, or if it's concave up or down. And the vertex form should also have an a value here as well. So that's how we changed there. So standard form was interesting. B value did something even more interesting. In this video, however, we're going to concentrate on intercept form. All right, so it looks like this. And this might look familiar. Let's take a look why. Flashing back, looking back on something we've learned a few years ago, and we've talked about in this class as well, the Null Factor Law. We know that if you have something multiplied by something and it equals to 0, then either A is 0 or B is 0. The only way you can multiply two things and get 0 is if one of the two things is 0. We apply that principle to the idea of factored algebraic expressions as well. So here we have 3x times x minus 5, and that equals 0. If that really equals to 0, then that means either 3x is equal to 0 or x minus 5 is equal to 0. So we can set up those two little equations from this one and solve each one. This one solves for x equals 0, and this one solves for x equals 5. And you would see if you put 0 back in here, if you substitute it back in, this would multiply and become 0. If you substituted a 5 in here, you'd get 0 here, so that would multiply to 0 as well. So these are two possible values of x that make this equation work. Let's look at another one. We have this factored form, and it's also equal to 0. So one of the two factors must be equal to 0. So set that one equal to 0, or set this one equal to 0. Our two answers are x equals 4 and x equals negative 7/3. Okay, using that null factor law, we can now talk about intercept form, because intercept form kind of looks like a factored quadratic, doesn't it? Well, that's exactly what it is. So let's take a look at this intercept form parabola, and here's the graph for it. And let's set the y equal to 0, okay, and see what happens when we solve it, because that's what we're doing in the null factor law problems. We can set this equal to 0 and then solve this. So now that we've set that equal to 0, we can divide by 0.5 to get rid of the 0.5. So we have this simplified form here. The 0.5 is gone. Now each of these factors can be set equal to 0. X minus 3 equals 0, and x plus 5 equals 0, and we have our two answers. Now take a close look at those two answers we got from this one when we set it equals 0, and the graph. What do you notice? Well, I think that's a pretty obvious conclusion. When we solve a intercept form quadratic, when we solve for the x values by making y 0, we get the locations of the two x-intercepts. Very important point though, you should know that for sure. The parabola's intercepts on the x-axis are those two answers we get when we solve it like that. Now what's the vertex of this one? Well, we can see the vertex is right here. And now how can we use the x-intercepts to find the vertex? Let's take a look at that. So the vertex was -1, -8. How can we use the x-intercepts to find that vertex? Well, the interesting thing is that the vertex is exactly halfway through, right? Because the axis of symmetry is the halfway point between the x-intercepts. So if the vertex is halfway between these two, then it's like finding the average of those two values. So here's -5 plus 3 divided by 2. So -5 plus 3 is -2 divided by 2 is -1. Notice that is the x value of the vertex. We're basically saying the vertex x value lies at the mean or average of those 2 points, and that makes sense. So now that we know that that is the mean location, the x vertex, then we can plug that back into here and find the y value as well. So that's what this summarizes here. To find the axis of symmetry, we can do p plus q, which means these two values added, and remember that they're the opposite of what you see here. You add those two values up, and then you divide by 2. So you're finding the average location right here. And then that whole point can be put into the function to get the whole vertex. Okay, so let's investigate intercept form in Desmos as well. We looked at the other ones in Desmos. Let's look at this one as well. So let me find it here. I'm going to go back to the original ones just to take a look again. This was a vertex form. Let's recap. The A value makes it wider when it's a decimal, or when it's negative, concave down, or when A is 1, it's the same as your normal parent parabola, which is x squared. We know the h and k are the vertex, so if I move h, it moves the x value, or the axis of symmetry. And if I move the k value, it's going to move it up and down, because that's the y value of the vertex. So remember, hk is the vertex, and h specifically axis of symmetry. In the standard form, the A had the same effect, right? The A, well, let me flip it over here. Okay, let's see, change this a little bit. Okay, the A makes it wider or narrower, or it keeps it concave down when it's negative, or concave up. See, getting narrower or wider. Okay, C value was important. Remember, here's the C. C value is 2.6, and here's our y-intercept. So the C value was your y-intercept. So that was standard form. And now let's jump to intercept form. So here's intercept form. You can see it here. A value, same effect, right? Makes it either narrower when A becomes big, or wider when A is a decimal, or concave down when A is negative. See, it's concave down now. So that's A, same effect, always the same effect. And now P and Q, remember P and Q are those two values, and those are x-intercepts. So let me move this and show you what happens. Okay, check it out. So P value is 4.1, Q value is 0. So my x-intercepts are 0, 4.1. So let me change the Q as well. There, I made Q -2, and P is still 4.1. So look, -2, 4.1. So P and Q are our x-intercepts, and as I change P and Q, those two things change, the x-intercepts change like that. So really interesting. And of course, we talked about the vertex being exactly halfway between those two. All right, great. So that is our look at parabolas in Desmos. Let's continue algebraically looking at them. So now in this one, we are going to take these two intercept form quadratics, and your job is to find the x-intercepts and the vertex, and also the y-intercept. So the y-intercept can be found maybe by changing these to standard form, and to change these back to standard form, you can just multiply this through, right? Multiply that, multiply this, and you'll get back to standard form. But keep it in this form to find your x-intercepts, of course, because that's where you have to set this equal to 0 and solve. Let's try. All right, so in A is greater than 1. Actually, A is 1 right here. So that means it's a concave up parabola. The vertex will be a minimum. We used our P and Q values. P is 4, Q is 2. Remember, they're the opposite of what you see. When you set this equals 0 and solve each of those, they become the opposite. So we have those two values, and it tells us the x-intercepts at 2, 0 and 4, 0. And our vertex is exactly halfway. Remember, we add them up, divide by 2. We find out the vertex has an x value of 3, which is the average of the x-intercepts. And then we take our 3, put it back in the function, and we get our y value. So we now have the whole vertex 3, -1. Okay, so there's that one. Try the same thing in B. All right, check your work for B here. It's concave down because A is negative. We can find our x-intercepts as -3, -1. We can find the location of the vertex by averaging those. And anyway, check all the details there. Make sure you got it all right. And the y-intercept can be found again. Oh, it's interesting. So they didn't change it to standard form to find the y-intercept. They just said, hey, at the y-intercept, x is equal to 0. So if you make x equal to 0 and solve, and that's what's happening right here, when x is made equal to 0, you end up with the value of the y-intercept. So make sure you understand that process as well. Okay, so we've talked about recently about intercept form, but now let's take a look at how do you change from standard form to intercept form. How do you go from there to there? Well, that's going to require another flashback, looking back in time. It's all about factoring, because when you look at this, clearly this is a factored form of this. So let's remind ourselves how to factor. If you have a trinomial where a is 1, then we just say, hey, those are our ABC values. A is 1. AC goes on top, B goes on the bottom. So A times C is -28, B is 3. We think of two numbers that multiply to -28 but add up to 3. Those two numbers are 7 and -4. So when a is 1, that tells you this standard form can just factor right into this factored form here. Easy. And now we have standard form to intercept form. Well, what about when a is not 1, like this? A is 3 here. We still begin by doing a times c here, so 6. We put b here. We still look for two numbers that multiply to 6 but add up to 5. They are 3 and 2. And then now we take this part here, the 5x, and we expand it into those two numbers we found. So 5 becomes 3x and 2x. Now we do what's called grouping. We group the first two, group the second two, factor out whatever we can factor out of each one, and then we have a common factor, and that common factor can multiply by 3x plus 2 to get that. So we have factored here by a process called factoring by grouping. So we've taken standard form quadratic and changed it into intercept form right here. Try one more. Factor this one. And now check your work. Oop, let me go back. Check your work and make sure you factored correctly. So now we're going to use that approach here. So we have these standard form quadratics, and it's asking you to change them into this form. Well, that's our intercept or factored form. So factor it, and after that you should be able to get the x-intercepts, the y-intercept, and so on and so on. So let's try. Okay, for a, there's the factored form. Therefore, our x-intercepts are -8 and 2. Remember, they're the opposite signs. And our y-intercept is 0, -16. And that, again, we got by placing a 0 in for x and solving. So if you had 0 there, 0 there, you'd have 8 times -2, which is -16. That's our y-intercept when x is 0. All right, try b. Okay, b is easier factoring because we don't need to do that a trinomial factoring. We just have two terms here. We can just factor something out of both of them like that. Okay, then each of these can be set equal to 0, and we get our two x-intercepts. There they are, and our y-intercept is at 0, 0. How about try c now? Okay, in c we need to use the longer technique here. We have an a value that's not 1, so we can begin by setting it equal to 0. We can then do a times c is -42, b is 11. What are the two numbers? Those two numbers are 14 and -3. Now we can expand this like this. Now go ahead and try the grouping technique to see if you can factor it. Let's check our work. Common factor of x plus 7, and therefore factors like this. Now set each of these equal to 0 by the Null Factor Law, and we get this and this. Those are our two x-intercepts. So our x-intercepts are 1.50 and -70. Our y-intercept, you can look at either the original standard form, -21 here, or you can put 0 into this form as well. If you put 0 here, you get -21 as well. So that's our y-intercept, 0, -21. All right, and now that is ready to be graphed. You can also continue and find the vertex. Remember, the vertex can be found by -b/2a here. So what would the vertex be? And you can also find the vertex here by finding the midpoint, right? The average between these two, which will give you the same vertex value as we got by using -b/2a over here. All right, so all the ideas coming together. Let's see if you can try these two. So try a. It says this function, which is now in intercept form, can be written like this in standard form. So multiply that through, write it in standard form. Then write what values of a, b, c are, find the x and y intercepts, and so on. Try b after that as well. And now let's check our work. So there's a. Multiply, change the standard form, a, b, c values. X-intercepts can be seen from the original intercept form. Y-intercept can be seen clearly in this form. And yeah, and b is right there. Check your work carefully. All right, so we've looked at a lot of things. Let's summarize it. There are three forms of quadratics. One is called standard form, where we can get the y-intercept from here, and we can get the vertex or axis of symmetry using this little formula. Another form is vertex form, where the vertex is at h and k. And the third form is intercept form, looks like this. That can also be called factorized form, and those values there, p and q, are our x-intercepts. Good summary. Here's another good summary. Maybe pause and take a photo or take a look at that, read through that. It summarizes everything we've looked at in the last couple of videos. All right, now that you've recapped or reviewed quadratics in three forms and all the little formulas and how things they work in there, Let's see if you can answer this TOK question. How would you choose which form to use? Why is one more important than another, and when is it? Thank you for watching. See you soon.